Hi, my name is Eric Hammersmark. I am a product management engineer with F5 Networks. Today, I'm going to be demonstrating for you F5's long-distance VMotion solution. VMware's VMotion technology allows you to migrate a running virtual machine from one physical host to another, but only between very well-connected machines. With F5's WAN optimization technologies, we can enable VMotion events to succeed over wide area networks between data centers, while preserving not just user sessions, but even active client connections. In addition, F5's iControl API allows all aspects of these events to be automated or orchestrated. These capabilities are key to implementing a dynamic cloud migration solution. F5's WAN optimization iSession tunnel uses symmetric deduplication, compression, and TCP optimization to substantially reduce the bandwidth requirements of a VMware VMotion event. F5 has also implemented EtherIP, which we will use to create a layer 2 bridge between two data centers that allows the original data center's big IP to stay in communication with the VMotion server, preserving client connections. We will be using F5's Global Traffic Manager to direct load test traffic in proportion to each data center's capabilities, and the entire process, including modifying big IP pools, waiting for a portion of the connections to bleed off of the server to be VMotioned, and the VMotion event itself, will be managed through a workflow in VMware Orchestrator. For reference, I will begin by launching a storage migration over an unoptimized link I'm migrating only the storage of a not running VM over a simulated T3 using a WAN emulator to restrict bandwidth to 45 megabits and introduce 20 milliseconds of latency. This diagram displays the major components of this demonstration. I have two data centers, one big IP in each data center, one VMware ESX server behind each big IP, and a number of virtual machines on each ESX server. I also have a load generator creating a small volume of traffic across the entire application, as well as a big IP GTM load balancing between the two data centers. Finally, I have a second emulated WAN link, again at 45 megabits, and 20 milliseconds of latency. These objects, their relationships, and the connections flowing through them are all being drawn on the fly based on the current states of the systems. As it is illustrated in the diagram, I have established an optimized tunnel, a WAM iSession tunnel, and an EtherIP tunnel between the data centers. I will use the optimized iSession tunnel for VMotion and the EtherIP tunnel for client traffic. I'll begin by opening my client and starting a long download, letting GTM choose a data center and LTM choose a pool member for my connection. Since data center A has 3 active servers and data center B has 2 active servers, you can see that GTM is load balancing between them in a 3-to-2 ratio. GTM has load balanced me to data center A to server number 3. We will now use the VMware Orchestrator workflow to migrate server 3 from data center A to data center B, along with its storage. This is the VMware Orchestrator client. I will now launch the workflow. The workflow asks me to select a server. To VMotion, I will select server 3. And to target ESX host, I will select the ESX host in data center B. The workflow will now disable server 3 in data center A, wait for its connections to bleed off, and then begin a storage migration from the NFS server in data center A to the NFS server in data center B. After that storage migration, it will perform a live migration. It will add the server to the pool in big IP B and remove the server from the pool in big IP A. And none of this will interrupt the download that I started just a minute ago. You can see the progress down here. As you can see in the vCenter client, the storage migration is proceeding, and you can see here the unoptimized storage migration we started before we launched any of this. Notice that since one of the servers behind Big IP A is disabled, GTM is now load balancing between the two data centers using a 2-to-2 ratio. Once server 3 starts running behind Big IP B and data center B, GTM will begin load balancing in a 2-to-3 ratio. In addition, Big IP A will learn that server 3 is now on the other side of its Ether IP tunnel, and we'll start directing traffic to server 3 over that tunnel. Big IP B will pass the server 3's reply traffic for my connection only back over that tunnel, back to Big IP A, which will then pass it back to me. So we can see then that the optimized storage migration has now almost caught up with the unoptimized, and we'll very soon pass it all together. Here we can see the orchestrator client letting us know that it is waiting for the storage VMotion to complete before it proceeds with the workflow. Those progress meters can be a little bit misleading. While the cold storage migration, which we started first, will be measured all the way up to 100%, a VMware storage VMotion operation is typically measured up to a milestone at around 65%, and will jump from there right to 100%. Of course, both of these operations are moving approximately the same number of bits between the same two NFS servers over identically simulated WAN links. The optimized storage migration is likely to take about 3.5 minutes in total, while the unoptimized storage migration, which started more than 5 minutes ago, is unlikely to finish at all before the entire workflow is complete. So as we can see right here at 65%, that storage VMotion operation is wrapping up, and it's about to jump to 100%. It has moved the entire storage for server 3 from the NFS server in data center A to the NFS server in data center B. And if you notice, the progress on my download has been continuous throughout this entire operation. Now that the storage migration is complete, the live migration is taking place. Once this is complete, we should see my download traveling over the tunnel to server 3 and back over the tunnel from server 3. And we'll see GTM load balancing between the data centers in a 2-to-3 ratio. So now we can see server 3 is running on ESXB. We can see that my traffic is flowing through both big IPs and over the WAN. And now we can measure that GTM is load balancing between those data centers in a 2-to-3 ratio. This concludes this demonstration. As you can see, F5 solutions have allowed us to VMotion a running machine and its storage over a 45 megabit link in a matter of minutes, to preserve client connections, and to do it all with just a few clicks of the mouse in VMware Orchestrator. For more information about this solution, please visit www.f5.com/VMware. Thank you.